Hello everyone, welcome to 𝐿lustraca. Today we are going to discuss about the stability index that is being used to find whether the particular story of a structure is sway or no sway structure, or you can say no sway story, based on which we find the effective length factor for the column of that particular story. Okay, so let's get started. For the I can say checking purpose, we are going to use this ETABS model, which is already designed as per ductile design criteria of IS 13920/2016. And we will see what is the, you can say, what the software is taking as stability index and what we are getting as per our calculation. Okay, so now if I just jump into the code of IS456 2000 NXE, you can see here the effective length of column, where before finding the effective length we need to understand first whether that particular column of the particular story is to be considered as sway column or no sway column. Okay, so in that case it says, if you see the E2, to determine whether column is no sway or sway column, stability index Q may be computed as given below. Q equal to PU summation of PU, though it is written PU, that means the ultimate you can say axial load, but we are not going to take it ultimate, because if you see top and bottom, both ways it is written U, maybe by mistake, because when you find the ratio, ultimately you're going to get the similar kind of ratio. Okay, similar ratio. So what I will do, I will not take I will not consider this as ultimate load, because here nowhere it is written, though they have given U. So summation of P, I would say, so in multiplied by delta divided by H, capital H multiplied by small h's. So it is nothing but axial sum of axial loads on all columns in the story. That means nothing but, it is nothing but the total vertical load that we are getting. Okay, total vertical force that we are getting, and then we have this delta U, which is elastically computed first order lateral deflection. This is nothing but the relative displacement of particular story. Okay, so you just you have to find out the relative displacement of a particular story, which is nothing but the drift that we call. Okay, HU, capital HU, is nothing but the total story shear, or you can say total lateral force acting within the story. What is the total story shear? And H is nothing but the height of the story. Okay, so using this formula, very simple formula is given, we have to find out the you can say the stability index of the structure. So what I will do, I will go here in this structure, and let us suppose we will be finding the stability index of this particular story. Okay, of this particular story. Okay, so this is my, if you see, if I talk about the floor, this is first, second, third, fourth and fifth. So if I want to find out the stability index, suppose this column, I have to get the total load on you can say above this column. Okay, so in this story, in this floor, what is the dead load that we have, total dead load that we have from above and including that floor, that will be coming, you can say, below this story, right? So if I just go to the elevation view of any of the elevation, suppose, sorry, this is plan. If I go to the elevation view, suppose elevation 1, so I am going to find out the stability index of this story, correct? So first of all, we need to get the axial load on the all the columns. So summation of axial load we need to find out, correct? So for that, the load above and this floor load we need to find out, correct? So what I will do, I will go here. It is already analyzed. So in ETABS, you can do the same in STAT also. You can say earlier many of you have used this mass modeling, right? You have given some pinned you can say point here, right? You have assigned some pin support to find out the vertical mass of this particular story. So like that you can do this also. So what I will do, I will go to here, you can say the story forces I need to find out. So I will go to an tables, and then I will go to structure output, and here you can see the story forces I have. So I'll just right click and show table. So the story that for which I need to find out the story forces, so it is the first, second, third and fourth story. So I'll just right click here and I will get the story 4 here. Okay, I got the story 4 and I want the load at the top of the story 4, right? So this is my story 4. I want the load at top, so I will make it top. Correct. Okay, so now what I will do, here you can see I have got the axial loads. So basically I will just select the load cases. So I'm going to use the dead load, all the live loads and the response spectrum loads here. Okay, correct. I'll click on apply multiple item filter. Fine. So this is my you can say total vertical load that I have. Correct. This is my total vertical force, or you can say axial load, that I will be having on all the columns. So I'll just copy this. I will copy it. So press Ctrl C, and what I will do, I will take it to a Excel sheet. So I will just write it. Suppose I will just paste it first. So I'll paste it here. Ctrl V. Sorry, I have not copied. Let me just go here. Ctrl C, go to Excel and Ctrl V. Correct. So if I just do the calculation here, suppose total axial force on all the columns. Okay, so equal to, I will get the sum of all this. Correct. Let me give an equal to sum of all this and press enter. So I got this in kilonewton. Correct. So kilonewton. Fine. So I got the total you can say load, which is nothing but our summation of P. Correct. So now what I have to get next, I need to get the delta, which is nothing but the relative displacement of the structure, so of the story. So what I will do, I will close it. Here I will go to you can see deformed shape also, and by seeing the deformed shape you can find out the relative displacement, or else in ETABS we have this you can say option to see the response plot. So I'll just go to display and story response plots, and you can see here we have the maximum story displacement, and I will find out, suppose for one direction, so it is suppose RSX for X direction. So the response spectrum X direction force load I am taking, and as I am finding out the, you can say, relative displacement of this story, so it will be displacement of this minus displacement of this. Correct. So it will be my relative displacement. So here you can see we are having it in mm. So if I see here, we have story force relative displacement of story 4. It is nothing but you can see 20.2794. Okay, it is written 20.279477. So I will just write it here, 20.279477 mm. Correct. This is for story 4. And for story 5, if I see, for story 5 I snap here, it is right, it is, if you see, it is written 15.71399. so I will just write it. For story 3 it is 15.71399 mm. If you see here, there will be an option snap to, so that is what I am writing actually. If you see here, it is 15.71399. correct. Okay, so this is what I got. Now if I want to find out the you can say relative displacement, so the relative displacement equal to 20.279477 minus 15.71399. okay, so if I just verify, okay, so let us just calculate it. 20.279477 minus 15.71399, so it is 4.565487. I will write this exact value. You can say write like 4.565 also, that is not an issue. So I'm just writing. So if I write relative displacement of the story, displacement of the story. So I'm just writing this in Excel so that we can calculate it easily. Okay, so only this purpose I am using this Excel. So it will be equal to as I calculated, which is 4.565487. 4.565487. It's in mm. Correct? Then we need the story shear for this particular lateral force. Okay, for the lateral force I need the story shear of this particular story, which is my story 4. So same from story forces, I can say get the story force for this particular story. I'll click on show table. Here I will find story 4. Load I will select RSX, and I need at the top, so I'll just make it top. You can see Vx, if I see, it is 522.2812. So I'll just copy this 522.2812. So I'll just make it story shear. I will write it here. Story shear. If I denote it as capital H, okay, equal to, let me copy this, Control C, and I will paste it here, Control V. So this is my story shear. It will be also in kilonewton. Fine. So I got the summation of P, right? I got the sum of P, so I'll just write it, sum P. I can add the symbol also, but for now just writing it like this. And a relative displacement, so I can say this is my delta, right? This is my delta, and this is my story shear H. Now I need the height of the story. So height of the story, which is small hs, so equal to, then that also we can find out from here itself. Sorry, if I go here, you can right click on this column and you can see it is of 3 meters, so it will be 3000 mm, because everything we have written in mm, the length. So I will make it as 3000 mm. Correct? Fine. So now if I want to find out the stability index, it is just a simple formula. So I will write stability index, which we denote in Q. So it will be equal to, we all know, so it is nothing but summation of P multiplied by delta by H multiplied by HS. Correct? This is my Q equal to. So I can just do the same here. So I will just click here. I will do summation of P multiplied by delta divided by uh, capital H, which is my story shear due to the lateral force, multiplied by my height of the story. So I'll just press enter. Here you can see it is 0.013 we are getting. So basically it is less than 0.0 0.004, sorry, 0.04 most probably. Let me just check. 0.04, correct? Yes, 0.04. So that means that particular story is no sway, and the column is also need to be designed as no, you can say for no sway column, right? No sway column means the stability, the K factor that you are going to find. You are going to find the K factor based on this particular figure, which is figure 26 for no sway column. If it is sway column, then you need to go to this particular figure, which is figure 27. So as it is no sway column, so in that case, obviously the effective length of the column will be reduced, correct? So now we will cross check whether the software is also giving us the similar kind of result or not, correct? So for that, my structure is already designed. I'll just go to here, concrete design, and I'll go to display design info, and suppose I will you can say apply this longitudinal reinforcement. Fine. So for this column itself, I'll just right click on this, and if I go to details for any combination, suppose this is my critical combination, so I'll go to details, and here I will go to flexural details. So if I just zoom it and go down, here you can see the effective length factors X per NXR E. So here you can see that about major bending. So just let me show you first what is that called. So if I go to 3D view, and if I go to the you can say this you can say rendered view, so you can see the major dimension of the column. The major dimension of the column is oriented along X direction. So obviously we know if this is my column and we have two axes, so obviously the axis which is perpendicular to the major dimension, it is my major axis, because when we have the moment about this axis, okay, so as we have a higher dimension, so the moment resistance of this particular column about this axis will be higher, right? So as we found the stability index along X direction, that means about its major axis, so we will check the you can say we will check the major the stability index for major axis only, correct? So I will go to elevation view, earlier this one. I'll go to display design info and longitudinal reinforcing, right click. This is the critical combination, details and flexural details. So here I'll just zoom this. So it is the framing type ductile frame, because if you are choosing ductile frame, then only it will be calculating the Q factor. Okay, both sway and you can say K sway and no sway is calculated. But if I just you can say focus on this major bending, and if I see the Q factor, so the Q factor that the software is calculating is around 0.012586. So we can say it is around 0.013. So in our Excel also we got 0.013. Some you can say difference in the point, but it is not that high. Okay, so that it is exactly same, you can say 0.013. And based on this, it has calculated the K factor. As it is no sway, so you can see the K factor is very less. It is less than 1 also. Okay, so here you can see the K factor for no sway and K factor for sway both are calculated, but when it is considered in the design, so the considered one is for no sway, right? So this is a very simple calculation. Any software you can cross check. In ETABS, the ETABS is capable of calculating the, you can say, effective stability index and effective length factor, but STAD is not capable. So in that case, you can use such method, though when it is a small structure, it is possible to calculate manually like this, but in case of bigger structures, it may be a bit headache. So those who knows VBA or OpenSted, I don't know whether it is possible or not, but maybe with some you can say effort, we one who is you can say aware of OpenSted and VBA, they can create some automation tool for creating, I can say, calculating this stability index and effective length factor from the STAD model also. Okay, so do have a look if you know about these programming languages and the OpenStat, so it will be very useful, and please do share with us also so that we can use if you make. So this is how we calculate the stability index. Even the software calculate the stability index, and we have already checked that the result that we are getting in the software is also matching with our calculation result, right? So this is it for this video. I hope this video is helpful for you. What I have done, I have made one, I can say, very simple basic calculation sheet. You can see here for effective length calculation from the STAD results. So these, like whatever we have done manually now, so all these values like the story share and the, you can say, relative displacement, all this you need to put manually only. I have not made any automation tool. It's just a calculation sheet, and for the calculation of, I can say, beam stiffness and column stiffness also, I have made this sheet here, and ultimately you will be getting this ELY and ELZ parameter, which is the effective length factor parameter for the STAD design parameter. Okay, so this is a very simple sheet. So those who are already I can say enrolled in my STAD and ETABS course, they will be getting this exclusively. And like this is a very simple calculation sheet. You can also make whatever I have shown now. So this is this first page. If you see here, this first page actually calculating the stability index using the same method that I have just shown. Okay, so you just have to put these values and it will just calculate. So as I said, it is not a automation tool, it's just a calculation tool. So you can also create this kind of Excel sheet for your fundamental calculations, and if you know automation like VBA and OpenStat and Python, so you can automate this kind of, you can say, sheets, connecting those with the softwares, correct? So this is it. I hope this will be helpful for you, and if you have any suggestion or any doubt, you can always write me in the comment box so that I can clarify those as early as possible. Thank you, and see you in the next lecture.